Question number 6. You are asked to use three different forecasting techniques to predict future demand for April through December. And then you need to calculate the mean absolute deviation to identify which one is the best method to predict future demand in this data. For 3 months moving average first, like you did in question number 1, you can use the average function in Excel in order to forecast the future demand for April. So average of prior 3 months. And then you can just drag it down to use the same function in Excel. December forecast will be based on the actual demand in September through November. We will get a forecast for December 78.3. Next, for weighted 3 months moving average, we will use different weights of 50% of the actual demand for the most recent month and 30% of the 2 months ago and 20% of 3 months ago. I already added a column to our data table to indicate the weights for the 3 actual demand figures that will use it creating our weighted moving average. Using the weights and the actual demand figures from January through March, and plug them into the weighted moving average equation. We can come up with the forecast for April is equal to zero point 0.5 our first weight times and 65 actual demand in March plus zero point 0.3 our second weight times 65 actual demand in February plus zero point 0.2 our third weight times 59 actual demand in January. The forecast for April using weighted moving average is 63.8. Similarly to forecast for May through December, after fixing each weight by adding a dollar sign in front of column and row and column and row and column and row. And you can just drag it down to December. Now you can move on to the December to check it out. You can come up with the forecast for December is equal to zero point 0.5 our first rate times 83 actual demand in November plus zero point 0.3 the second rate times 75 actual demand in October, zero point 0.2 our third rate times 77 actual demand in September. Finally, we got a predicted demand for December 79.4. Next, for single exponential smoothing forecast, we need only 3 pieces of information. The most recent forecast, the actual demand that occurred for the forecast, and smoothing constant alpha, which is zero point 0.2 in this case. So our forecast for February would equal the forecast from January, 63 plus smoothing constant alpha times the forecast error in January. The forecast error is to find its actual demand in January 59 minus what was the forecast for January 63. We got a forecast for February is 62.2, lower than the forecast for January, since the actual demand is lower than we expected in January. To continue, after fixing the smoothing constant by adding the dollar sign in front of, and then you can just drag it down to calculate the forecast for each month from March through December respectively. Then we can check that our forecast for December would equal the forecast from November 72.2 plus alpha zero point 0.2 times the forecast error in the prior period, November. Forecast error is to find its actual demand in November 83 minus what was forecast for November 72.2. We get a forecast for December is 74.4. Essentially, we have taken November forecast and adjusted higher since the forecast in November was lower than the actual demand in November. Next, we are required to use absolute deviation for determining which one is the best technique to forecast future demand in this data. What you are doing is you need to compute the absolute deviation of each month in each method. In this exercise, the absolute deviation of April is defined as the absolute value of the actual demand, 67, For April, minus the forecasted demand, 63 in each method and each month. For this, we have to use the ABS function in Excel. Similarly, to continue the following the same methodology in the remaining month and each method, by adding the dollar sign in front of a column C, you can just drag it down to December and then to the right, exponential smoothing method. Now we can calculate the mean absolute deviation, which is the average of all the absolute deviation for each month. The mean absolute deviation here would be the average of 9 absolute deviation numbers shown here, and you can just drag it down to the right. For 3 months moving average, MAD is 4.1. For weighted 3 months moving average, MAD is 3.6. For single exponential smoothing, MAD is 6.9. As the result of MAD calculation, the lowest one is the weighted 3 month moving average. So you can say that weighted 3 months moving average is the best forecasting technique for predicting future demand in this dataset. Let's move on to next question. For question number 7, you are asked to use 4 different forecasting techniques: 3 month moving average, 5 month moving average, exponential smoothing, and different alpha value, zero point 0.2 and zero point 0.4. So, and then you need to calculate the mean absolute deviation to identify which one is the best method to predict the future student registration at Westchester. For 3 month moving average, in order to forecast the future registration for week 4, you need to take the average of prior 3 months. You can use the average function in Excel to calculate the forecasted registration for each month from week 5 through 18. You can just drag it to the right to use the same function in Excel. Next, for 5 months moving average, in order to forecast the future demand for week 6, you need to take the average of actual registration from week 1 through 5. Take the average of a prior week 1 through 5. To calculate the forecasted registration for each month from week 7 through 18, you can just drag it to the right to use the same function in Excel. For single exponential smoothing forecast, we need only 3 pieces of information: the most recent forecast and the actual demand that occurred for that forecast, and a smoothing constant alpha here, 0.2 and 0.4 cases. For smoothing constant alpha 0.2 case, so our forecast for week 2 would equal the forecast from week 1, 45 plus smoothing constant alpha times the forecast error, actual demand 45 minus the forecast 45. In this case, we got a forecast for week 2 is the 45, the same as the forecast for week 1. To continue, after fixing the smoothing constant by adding the dollar sign in front of column and row, and then you can just drag it to the right to calculate the forecast for each week, week 3 through week 18 respectively. For smoothing constant alpha 0.4, for our forecast for week 2 would equal the forecast from week 1, the forecast value 45 plus the smoothing constant alpha 0.4 times the forecasting error, actual demand minus the forecast value of week 1, which is 45 as well. So our forecast for week 2 would equal the forecast from week 1, 45. To continue, after fixing the smoothing constant alpha by adding the dollar sign in front of the, again, you can just drag it to the right to calculate the forecast for each week from week 3 through week 18. Next, we are required to use absolute deviation for determining which one is the best technique to forecast future registration in this data. So you need to compute the absolute deviation of each week in each method. In this exercise, the absolute deviation of week 6 is defined as the absolute value of actual registration number in week 6 minus 33 minus the forecasted number in week 6 for each week in each method. In this case, 41.7. For this, we have to use the ABS function as well in Excel. Similarly, to continue following the same methodology in the remaining weeks, you have to drag in to the right for calculating absolute value of the actual registration number minus the forecast registration number in each week, respectively. To continue for other techniques, after fixing the actual demand of each week by adding the dollar sign in front of 6th row, and then you need to drag it to the right again. Apply this fixing law 6 for each week from week 6 through week 18. And then you can just copy and then paste to other techniques for calculating the absolute value of actual demand minus the forecasted demand in each week in each method, respectively. Now we need to calculate the mean absolute deviation, which is the average of all absolute deviation for each week in each method. The mean absolute deviation here would be the average of 13 absolute deviation numbers shown here by taking the average of sum of the absolute deviation over the 13 weeks. Average of absolute deviation of over the 13 weeks. To continue for other techniques, you can just copy and paste to apply same function in Excel for calculating mean absolute deviation. For 3 months moving average, MAD is 11.4. For 5 months moving average, MAD is 11.2. For single exponential smoothing with the alpha 0.2, MAD is 10.9. For second single exponential smoothing with the alpha 0.4, MAD is 11.9. So as the result of MAD calculation, the lowest one is the single exponential smoothing with alpha 0.2. So you can say that single exponential smoothing with alpha 0.2 is the best forecasting method for predicting future student registration in this case. Let's move on to next question.